Alright, hey guys. This video will be going over the multiple choice answers for the IMV exam 2. And I'll be using Desmos a lot in the video, but everything I do on Desmos today, you can do on your CAS as well, so that's fine. Desmos is just easier. Okay, let's go. Question 1. What is the period and range of this function here? So what I'm going to do is I'm going to go to the CAS, and I'm going to define the function we have. X minus 1 plus tan of pi on 5x minus pi on 3. Then I'm going to go to graphs and then put that in. And as you can see, obviously the range is r, goes on to infinity. So that immediately crosses out b and c. And to find out what the period is, what we can do is we can see what f of 0 is equal to. And then if the period is 60 pi, well then f of 60 pi should also equal negative pi on 3 minus 1. And it's not. So that means that f of 60, which is also equal to negative pi on 3 minus 1, is the period. So D is the answer. Alright, which one of the following holds true for all real values of x? Okay, so that's just going to be C. And the reason that is because if you look at it more closely, this is really just sine squared theta plus cos squared theta is equal to 1. So the Pythagorean identity, and then they just made it a little harder by letting theta equal cos of x. But it still holds true no matter what theta is. So yeah, C is the answer for that. Question 3, let f of x equal to the natural log of p of x. Given that both f of x and f negative 1 of x are defined over all real numbers, okay, so what does that mean? If f negative 1 is defined over all real numbers, well, that means that domain of f negative 1 is equal to r. But we know that the domain of the inverse of f is equal to the range of f. So the range of f is also equal to r. And it also has to be 1 to 1, obviously. Otherwise, f negative 1 wouldn't exist. So we need to find a function p of x such that this here is 1 to 1, has a range of r, and a domain of r. And to do that, we can actually just go ln of e to the x, like this. So this is an example of when all the conditions are satisfied. And then, so first one, p of x is equal to p of negative x. But since we just found that p of x equaling e to the x is one of the solutions, obviously e to the x doesn't necessarily equal e to the negative x, so we can cross that out. And then same with d over here. So p to the negative 1 of x is greater than 0. You know, p to the negative 1 of x would be ln x, and graphing ln x, obviously you can see from 0 to 1, it's below the x-axis, so it's not always greater than 0, so not d. And then for c, if p of x is periodic, so let's say it equals like sine of x or something, then that means that the natural log of sine of x is also periodic. And if something's periodic, that means it repeats. And if it repeats, it doesn't pass the horizontal line test, therefore it doesn't have an inverse because it's not 1 to 1. Therefore the answer is C. Alright, question 4. So same function, and they're both continuous over an interval d. Which of the following must be true? Okay. What can we do here? Alright, so first of all, these can't be true, because if they have turning points, then f of negative 1 isn't defined in D. And then out of these two, what we're going to do is we're going to look at the example when p of x is equal to the absolute value of x. So then p of x is equal to the absolute value of x, and then plus 1, so that everything is above the x-axis. Yeah, so absolute value of x plus 1. Then as you can see, what we can do is we can let d be the interval from, I don't know, 0 to 10. Doesn't really matter what it is. As you can see, from 0 to 10, it's obviously continuous, but then it's not really differentiable at x equals 0, is it? Because this is a sharp point. Therefore, you can't differentiate it at that point. So therefore, the answer is B, because it is continuous, but not necessarily differentiable. All right, next question. So same function again, and we need to find the gradient of f negative 1 of x at the point B. All right, so here we're going to let g of x equal to f negative 1 of x, and then we can actually put both sides into the function of f of x. And these two cancel, so we get that f of g of x is equal to x. And then we need to find the gradient of the inverse of f, which is the gradient of g. So to do that, we're going to differentiate both sides. To differentiate this side, we use the chain rule. So derivative of the inside function is the derivative of g multiplied by the derivative of the outside function. And derivative of x is 1. So this implies that g of g dash of x is equal to 1 over f of g of x. And we need to find it at the point B, so g of b, or 1 over f of negative 1 of b. So to find f of negative 1 of b, we can look at this. So if f of a is equal to b, then f negative 1 of b is equal to a. So this is going to be 1 over f of a. And then to find the derivative of f, we just have to differentiate this, which gives us the derivative of p over p. So when we substitute a, it's going to be, so derivative of p of a is going to be z, and then p of a is w. But then we need to find the reciprocal of this because it's a 1 over, so it's going to be w over z, which is c. Sorry about my voice, I'm a little ill. All right, so next question this is pretty easy actually. X squared x minus 3. All right, so from 0 to 2, well, obviously it's decreasing, so it's not a. From negative infinity to 0, it's increasing, but only up until when x equals 0, which is when it's not increasing. So if it was, it's actually, I think they meant to write negative infinity, not infinity to 0. But if it was negative infinity to 0, not including, then that would be the answer. Obviously not R, so the answer must be D, 4 to 9 on 2. So I'll choose somewhere there. All right, question 7. In the IMV school swimming club, lap times are normally distributed with a mean of 35. If a quarter of the members on the team are faster than 30 seconds, find the standard deviation. So we're given that the probability that it's faster than 30, so x is less than 30, is equal to 0.25. Then transforming this into the standard normal distribution, we get 30 minus 35 on sigma. So yeah, which is just negative 5 on sigma. And then to find out what this has to equal to, we're going to go to our CAS. We're going to go menu 553. We're going to put in the area of 0.25 to get negative 0.67449. So this has to equal negative 0.67449. And then solving, we get that x is equal to 7.41, which is A. All right, Zach is the star swimmer. Blah, 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 blah. Okay, so probability that Zach starts too early is 0.1. So we have a binomial here. Binomial n, we don't know what n is, and a probability of success is 0.1. Find the most time Zach can start until the probability he has at least one false start is 0.9. So probability that x is greater than or equal to 1 equals 0.9 implies that 1 minus the probability that x equals 0 is 0.9. 1 minus 0.9 to the power of n is equal to 0.9. So 0.9 to the power of n equals 0.1. So solving, we get equals 0.1. We get that n equals 21.85. So what that means is when n equals 22, he's going to have a probability that is greater than 0.9. But we want to find the most time Zach can start until the probability is the most times he can start given that the probability is less than 0.9, which occurs when, n is equal to, rounding down, 21. Question 9, consider the lines, when are they parallel? All right, to do this, we're going to rearrange both lines in terms of y. So there's going to be negative m over 2x plus 3 over 2, and y is equal to negative m plus 1 over m x plus 1 over m. And to find when they're parallel, well, their gradients have to just equal to each other. So m plus 1 over m is equal to m over 2. Just cancelling the negatives. So solve equals x plus 1 x. Okay, that x is equal to 1 plus or minus root 3, which is A. Alright, what is the maximum amount of asymptotes that the graph of y equals 1 over a quadratic can have? So the asymptotes occur when the denominator is 0. So when ax squared plus bx plus c is equal to 0. And this occurs when, the maximum amount of solutions this can have is 2. So therefore the maximum amount of asymptotes is 2. Alright, question 11. Let hn of x be the nth derivative of h0 of x, where n is 2p, so that's essentially saying that n is only even numbers, and h0 of x is equal to e to the negative x squared. How many axial intercepts does h of n have? All right, so to do this, let's graph e to the negative x squared. So as you can see, when n over here, when n is equal to 0, we have exactly 1 axial intercept, which is namely the y-intercept at 0, 1. So, 1 intercept. And then when we substitute 0 into all of these, this one's going to give us 0, this one's going to give us 0, this one's going to give us negative 1, and this is the only one that will actually give us 1. So just straight from literally the first iteration, we already know that the answer has to be D. All right. After surveying some of her friends, Emily has discovered that only 1 out of a sample of 5 friends think that caramel is the best ice cream flavor. Find, okay, 95% confidence interval. Okay, so immediately cancel out B and D, negative numbers. You can't have a negative sample proportion. Therefore, it has to be this or this. So let's see whether the upper limit of the confidence interval is 0.55 or 0.49. So P is equal to 1 over 5, which is 0.2, and the standard deviation is equal to the square root of 0.2 times 0.8 over 5. And the upper limit is going to be equal to 0.2 plus 1.96 multiplied by this. Okay, so let's do that. 0.2 plus 1.96, and we get 0.55. Therefore, the answer must be A. All right, probability of A, probability of P. What's the greatest difference between the intersection and the union, where A and B are independent? So since they're independent, then probability of A intersection B is equal to the product of these two, which is P cubed. And then using the formula, probability of A union B is going to be P plus P squared minus P cubed. If you don't know, the formula is probability of A plus probability of B minus probability of A intersection B. And the difference between these two is going to be this minus that, which is this. And we need to find which value of these will make this the biggest. All right, so let's do that. 2x cubed. So we had f of 1, that gives us 0, f of 0.3, f of 0.4, and f of 0.6. So clearly when p is 0.6, that'll give us the biggest difference. So the answer is D. All right, so let f of x equal x squared plus a. Using Newton's method, what values of c will lead to an infinite loop? Right, so if x0 is equal to c, well then x1 is going to be c minus f of c over f dash of c. And then, so let's see what that equals to. I'm just going to find f of x as x squared plus a, and then also define g of x as its derivative, which is 2x. So x1 is then c minus f of c over g of c, which is c squared minus a on 2c. So from here, when we want to calculate x of 2, well then we'll just substitute it back in, right? It'll be this number minus f of this number over f dash of this number. And if we want it to result in an infinite loop, well then this would just circle back to being c. So now we just need to solve this equation. So solve c is equal to this number minus f of this number over g of this number. Solving for c, we get that, okay, well, we need to look at the solution where a is greater than 0. So these ones is when a is less than 0. And then these ones are when a is greater than 0. So root 3a on 3, which is equal to c. All right, question 15. P of x is an 8th degree polynomial with 8 roots. What is the minimum amount of real roots that q of x can have? All right, so let's look at what p of x looks like. So 8 roots, 1, 2, 3, 4, 5, 6, 7, 8, something like that. P of x. And since this is the derivative of q of x, then each one of these x-intercepts will correspond to a stationary point on q of x, right? So q of x has 8 stationary points. Now, in the most extreme case, what can happen is that, let me just think about this real quick. Yeah, so in the most extreme case, what can happen is that every single stationary point is actually a stationary point of inflection. So something like this. 1, 2, 3, 4, 5, 6, 7, 8. And then it goes up. So in this very extreme case, there's only one real root. Therefore, the minimum amount is A, 1. Right, next question. If the sum and product of the solutions ax squared plus bx plus c is 0, what can we say about a plus... wait, what? If the sum... Okay, they made an error here. I think they meant to say if the sum and product are equal to each other. So let's just assume they meant that. So we know that x is equal to negative b plus or minus root b squared minus 4ac over 2a. So these, if essentially need to be equal to each other, sorry, their sum and product need to be equal to each other. So let's just type that out. So negative b plus square root of b squared minus 4 times a times c over 2a, and solve. So this plus its other solution, so that's the negative version, is equal to their product. Okay. And I'm going to solve for b. The heck? Oh, that's not a color. So b is equal to negative c, which is the exact same as a. B plus c equals 0. All right, question 17. The problem with this question is I looked at this exam before, and I'm pretty positive that all three of A, B, and C are correct. Yeah. So I'm not going to explain why. Actually, should I explain why? No, can't bother. But actually, fine, I'll do it. So odd and periodic. So that's a function like sine of x. Now, so period of n, that would actually make it sine of 2 pi over n x. And if you substitute f of x into any one of these integrals, of these 6 integrals, they will all equal 0, which makes every single one of these statements equal to 0. Now, obviously, there's a chance that, because, sine of 2 pi on n of x is not the only odd and periodic function with a domain of R and a period of n, but I'm pretty positive that all three of A, B, and C are correct. Please correct me in the comments if I'm wrong. But yeah, let's move on. All right, regular hexagon, line L, blah, blah, blah. The average value of L in terms of theta is, okay, so we need to find the average value of L. So to that, we need to find what L is in terms of theta. So let's take out this triangle. This is L, this is 1. I hope you can see that, because this is 1. Therefore, that also has to be 1. And this angle here is pi on 3. And the reason that is because if we get to draw a line here, since this is a regular hexagon, then all 3 sides will be the same. Therefore, all 3 angles have to be the same, which is 60. So that's going to be pi on 3. This is theta, and this hence is equal to 180, or pi minus pi on 3 minus theta, which is 2 pi on 3 minus theta. All right, so using the sine rule, L over the sine of pi on 3 is equal to 1 over the sine of 2 pi on 3 minus theta. So L is equal to sine of pi on 3 is root 3 on 2, sine of 2 pi on 3 minus theta. So that's what L is equal to, and we need to find the average value from 0 to 2 pi. But instead of doing 1 over 2 pi integral from 0 to 2 pi, blah, 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 that's going to give us an undefined value. The reason is because this triangle only works until theta is equal to pi on 3, and then afterwards this formula doesn't apply. So what we can do is since it's going to be identical everywhere, we don't really need to find it from 0 to 2 pi, we can just find it from 0 to pi on 3. So that's what we're going to do. So 1 over pi on 3, which is 3 over pi, just write that, times menu for 3 integral 0 to pi on 3 of square root 3 over 2 sine of 2 pi on 3 minus x dx, giving us this number, which is a. All right, question 19. So we have two functions here, and the range of these two composite functions have to essentially be the same. And okay, all right. Okay, for this question, I'm going to first define what we have here. Oh my god, I'm actually busting, but I'll go to the toilet later. Plus k, and then define g of x is equal to k minus ln 2 minus x. There we go. And then what we're going to do is we're going to find the range of f of g of x and g of f of x in terms of this number k. Okay, so f of g of x, the domain is, so we're just going to write domain f of g of x, hello, x, and we get this. So 2 minus e to the, all right, you know what, okay, hold on. 2 minus e to the x. All right, guys, I'm actually busting. I'll be back in like a few minutes, and I don't know how to edit the video and like cut it to when I'm back, so just wait for a couple minutes. I'll be back. All right, guys, I'm back. Yeah, I just can't be bothered editing the video and cutting out that one section where I had to pee. But yeah, just ignore that. Okay, so we found the domain of f of g of x, so now let's find the domain of g of f of x. So that's going to be domain g of f of x, 2 to k squared minus 4k plus 6. 2x k squared minus 4k plus 6. So these are the domains. Now from here, how are we going to find the range? So to do this, first what I want to do, I'm going to try and show you on Desmos. So first of all, k minus ln, or what? K plus square root of negative ln 2 minus x plus a minus 2. Yep. And then g of f of x is that, so k minus ln negative square root x minus 2 minus k plus 2. All right, so this is what we have here. And I know this blue graph here doesn't extend to infinity, but it's probably just a glitch with Desmos, but it does go to infinity. It should be going on to infinity. So as you can see, no matter what k is, the left endpoint is where the minimum occurs, and then the right endpoint just goes to infinity, right? So to find the range, to find this minimum value, what we can do is we can just substitute the left endpoint into f of g of x or g of f of x to find the range. So f of g of 2 minus e to the k minus 2, what the heck? That doesn't seem right. Maybe it's g of f of x. G of f of 2 minus e to the k minus 2. What the hell? Maybe I wrote it wrong. Hold on. Ah, because I wrote e, not like what e is actually. So f of g of 2 minus this e, sorry, to the k minus 2. Okay, yeah, there we go. That's much better. So k to infinity is what the range of f of g of x is going to be. And then same with u, we're just going to substitute the left endpoint, which is 2. So g of f of 2 is going to give us this, k minus ln 2 minus k to infinity. All right. And since it's said that both ranges have to be the same, so right, they're both some constant, a to infinity, that means that k is equal to k minus ln 2 minus k. And this is going to give us, I don't know, solve k equals k minus ln 2 minus k. K equals 1, perfect. K equals 1. Therefore, our domain here, when we substitute k back in, for f of g of x, it's going to be 2 minus e to the negative 1. And for g of f of x, it's going to be, oh wait, actually it doesn't matter. Oh no, it does. 2 x, putting 1 in there is going to give you 3. So there we go. And from here, to find R1 and L1, and R2 and L2. First, note that L1 and R1 is the domain of f of x, and we know that the domain of g of f of x is equal to the domain of f of x, using the laws of composite functions. So L1 is equal to 2, and L2 is equal to 3. Therefore, R1. R1 is equal to 3. Therefore, R1 minus L1 is equal to 1. So already we know the answer is B, but we'll just do it for the other one as well. And then the same thing for f of g of x. The domain of f of g of x is equal to the domain of g of x. So L2 is equal to 2 minus e to the negative 1, and R2 is equal to 2. So R2 minus L2 is going to be e to the negative 1, which is 1 over e. Therefore, the answer is B. Great. Last question. Oh, okay. Let me wipe my nose. Okay. Let f out r be a probability density function representing the continuous random variable x, and let p of x equal blah, blah, blah. So f of x, or the integral from negative infinity to infinity of f of x, is equal to 1. This is because the domain is r, so it has to be negative infinity to infinity. And then p of x is equal to the integral from negative infinity to x of f of x dx. Okay. All right. So, first of all, what I'm going to do is I'm going to cross out b. Reason being is because if b is correct, then a is correct. because like p of x always being greater than 0 implies that p of x is strictly increasing. So since we can't have two options being correct, B is not the answer. But I'm not going to go the other way because p of x p of x being strictly increasing does not imply that B is true. So the opposite is not true. So B is out. C is also out because y equals 0 and y equals 1 are not vertical asymptotes. They are horizontal asymptotes. So not U. So that leaves us with A and D. Now, D is wrong because imagine this. So imagine f of x looked something like this. It was two functions here which approach 0 at the ends, and then in the middle it was a flat line. So when we differentiate p of x, what we can do, actually ignore what I said. First, let me show you that f of x is equal to p of x. So here, from here, if we let the integral of f of x to equal capital F of x, then p of x is equal to f of x minus f of negative infinity. And this is 0. So p of x is equal to f of x. That means that p in derivative of p of x is equal to f of x. So that's how we know that this is true. But then you might be wondering, okay, so how does that not mean that f of b is equal to p of b? Is because p of b can't be differentiated at these sharp points, right? These are sharp points because it's a what am I, sorry, mind blank. It's a composite, no, not composite, it's a hybrid function, right? Which is not smooth at these 2 points, therefore it can't be differentiated at those 2 points. Therefore, the answer is A. And yeah, there we go. Those are the answers. For the MC, I'll release the answers for the extended response soon before the methods exam, don't worry. And yeah, thank you for watching. See you later.